Initially, the plan was to produce 80 P-39C fighters, but they ended up building just 20. In the fall of 1940, the Army Air Corps ordered over 300 of a completely new variant. This was the P-39D. The very next day, Bell received a new directive. The Army had modified the previous contract. Now, all previously ordered aircraft, starting with the 21st airframe, had to be built to this new standard. The D model largely mirrored the export version of the Airacobra. This was the version being built for Great Britain. The wings housed the same reliable Browning machine guns, but this time they were chambered in standard American .30 caliber. The ammo capacity remained the same. There were 270 rounds per gun for the nose-mounted .50 calibers, and 1,000 rounds for the wing-mounted .30 calibers. The fighter also received self-sealing fuel tanks. These had a total capacity of 120 gallons. The main armament was the powerful 37mm M4 cannon with a 30-round magazine. Cabin heating was solved in an interesting way. Instead of using a hazardous gasoline heater, engineers bled hot air from the radiator duct. This warm air flowed directly into the cockpit, creating slight positive pressure. This acted as a shield, keeping toxic gun gas out of the cabin when firing. From under the pilot's feet, that same air was routed forward into the nose armament bay. Special hoses from the radiator also heated the wing guns. This prevented them from freezing at high altitudes, which was a serious issue British fighters frequently encountered. For extra cold weather protection, they even installed blast tubes over the barrels of the P-39D wing guns. The low-pressure oxygen cylinders had no armor protection. All the radio equipment was strictly American-made. They planned to equip the fighter with the most advanced sets available at the time. Underneath the fuselage, designers included a centerline hardpoint for a drop tank. These came in two variants. The first held 75 gallons and was the standard combat tank. It nearly doubled the aircraft's range. It extended the range from the standard 600 to an impressive 1,100 miles. When empty, or if the pilot needed maximum maneuverability for a sudden dogfight, the tank could be easily jettisoned. This was done using a simple cable-operated mechanical release. The second drop tank option was much larger, at 150 gallons. It was used exclusively for long-distance ferry flights and could be just as easily dropped. If the extra fuel was not needed, a single bomb weighing up to 600 pounds could be slung on the centerline hardpoint instead. Historical records note that they initially wanted to install an advanced pneumatic desing system from Goodrich on the P-39D. At the time, these Deischer boots were already a well-proven technology. It worked like this. Hollow rubber boots were bonded to the leading edges of the wings and tail assembly. Compressed air was rhythmically pumped into them. The rubber would inflate and deflate. This cracked and broke off dangerous ice buildup. However, the idea of putting the system on the Airacobra ultimately had to be scrapped. The main issue was that the P-39 had no pneumatic system. To make it work, they would have had to mount a heavy compressor and air bottles. They also would need to route a complex network of plumbing throughout the airframe, so engineers took a simpler route. They stuck to an alcohol spray system for the armored windscreen. This had already proven successful on the British orders. They also added a similar anti-icing system for the propeller. The first prototype of this version was built using an already completed production airframe. It was modified right on the factory floor. It only underwent factory testing. With all the extra equipment installed, the fighter got noticeably heavier. The armor plating alone added around 245 pounds. As a result, its flight performance took another hit. The plane's top speed now maxed out at just 366 miles per hour. On top of that, it lost maneuverability at altitude. As soon as a pilot climbed above 13,000 feet, its speed bled off quickly. But with World War II ramping up, American military brass started placing massive orders for new combat aircraft across various manufacturers. This wave of huge contracts did not bypass the Airacobra. Despite some technical compromises, the total production run for the P-39D variant alone hit 923 aircraft. These production volumes went way beyond what the old Buffalo plant could handle. It employed around 2,000 people at the time. To solve this, under a government-backed defense program, Washington funded the construction of a massive new factory in Niagara Falls. It was built specifically to churn out Airacobras. At the new site, the production process reached a whole new level. Planes were now assembled on 4 parallel lines at once. The fuselages moved smoothly on special dollies. They were pulled by drag chains from one workstation to the next. The line moved at precise intervals. Picture this. At Station 5, workers dropped in the engine. At Station 6, they fitted the cockpit. And at Station 9, they bolted on the tail section. At the old plant, they could only dream of that kind of mechanization. Later on, Bell Aircraft bought another factory near Buffalo using its own funds. Thanks to improved tooling and economies of scale, the cost per aircraft started dropping fast. For example, while the P-39C cost $77,159 per plane, by the end of 1941, the price for a P-39D had fallen to $69,534. Compared to other fighters of the era, it was about 35% more expensive than the Curtiss P-40. However, the Airacobra still came out 35% cheaper than the later, much heavier P-47 Thunderbolt. Historians still do not know exactly how many D variants were actually built. Many sources point out that the initial order was never fully completed. A significant number of airframes originally slated to be standard P-39Ds were modified on the assembly line. They were changed to meet the new P-39D1 standard. This version ended up as a sort of hybrid. It mixed features from both the British and American variants. The P-39D1 packed a 20mm cannon with a 60-round capacity. Here is an interesting takeaway. Thanks to a higher rate of fire, the weight of fire from this smaller 20mm cannon actually surpassed the heavier 37mm cannon on the standard P-39D. By the numbers, it looked like this: 423 pounds per minute compared to 355 pounds. Altogether, the cannon and machine guns on the base D model fired 95 rounds per second. Meanwhile, the version with the Hispano cannon pumped out a massive 114 rounds per second. If you look at the armament in terms of muzzle horsepower, which factors in the muzzle velocity of the projectiles, the advantage went to the P-39D1 again. It stood at 1,406 horsepower versus 1,103. As for the rest of the armament, they decided to slightly reduce the ammo capacity for the 50 caliber machine guns, leaving 200 rounds per gun. Externally, the aircraft also saw some changes. A small aerodynamic fairing was added to the base of the vertical stabilizer. This design proved so successful that it was later retrofitted onto earlier P-39Ds. Engineers also made minor but crucial tweaks to the fuel system. They also swapped the electric starter for a more reliable unit. Otherwise, these two variants were virtually identical. Overall, historians estimate that around 200 P-39D1s rolled off the assembly line. The evolution of the aircraft did not stop there. The next step up was the P-39D2. Its flight characteristics improved significantly thanks to a more powerful Allison V1710-63 engine. This power plant delivered a solid 1,325 horsepower on takeoff. What is more, in a dogfight, pilots could engage war emergency power. They could squeeze out up to 1,550 horsepower. However, they were restricted to running it at this absolute limit for a maximum of 5 minutes. These higher loads meant the fighter had to be switched to a higher grade, 100-octane avgas. Because of the different internal specifications of the new engine, engineers had to fit a different propeller. Even though it looked exactly like the old one, it handled the extra power much better. The oil system was not ignored either. The oil tank capacity was bumped up to 13.7 gallons. To make cold weather starts easier for pilots and ground crews, designers added a special bypass line. Controlled by a dedicated thermostatic valve, it routed oil around the coolers. The old honeycomb-style coolant radiator was a thing of the past. It was replaced by a more modern tubular core that was a single unit. This was used rather than being split into two separate sections. Later production blocks of this model received larger wheels. The nose wheel was upsized from 19 by 8.1 inches to 20 by 5 inches. Meanwhile, the main landing gear tires grew from 26 by 6 inches to 27 by 7.2 inches. From then on, they were fitted with modern treaded tires. This replaced the smooth rubber used previously. Interestingly, the tread pattern was chosen based on the type of airfield. Block or star pattern treads were used for concrete runways. A diamond tread was used for dirt and grass strips. There were even special winter tires for snow and ice. They featured a unique reverse curvature. This meant the contact patch was concave rather than convex. Tire pressure on these new wheels was significantly higher than on older versions. This gave them a flatter, rather than fully round, profile. Finally, the main gear oleo struts were neatly covered with accordion-style canvas boots to protect them from dirt and debris. To shave off a little weight, engineers decided to remove the complex hydraulic charging mechanism for the cannon. Now, charging the gun could only be done on the ground. This meant that if the cannon jammed or misfired during a dogfight, clearing it in the air was physically impossible. The gun camera used to record hits was relocated to the right wing. The bulky flare tubes were replaced by a standard flare gun with cartridges. Parts of the fuel and oil systems were standardized with another mass-produced American fighter, the P-40. This plane was better known in the Soviet Union as the Tomahawk and Kitty Hawk. There were other minor tweaks too. For example, the aileron trim tabs were split into a dual setup. One was adjustable by the pilot right from the cockpit. The other was a ground adjustable tab. This tab was bent and set by maintenance crews before flight. On later versions of the P-39D, the older gun sights were swapped out for newer, more modern reflector sights. Their main advantage was that the reticle and aiming pipper were conveniently projected directly onto the combining glass, right in front of the pilot. A relatively small number of these aircraft were later converted into tactical reconnaissance planes. They were fitted with extra aluminum alloy armor plating. This effectively protected the oil and coolant radiators from enemy fire. In the tail section of the aircraft, 2 reconnaissance cameras were mounted. One was aimed aft for oblique photography. The other pointed straight down for vertical mapping shots. The exact camera setup could be reconfigured depending on the specific combat mission. The first P-39D fighters entered service with the United States Army Air Corps in February 1941. This allowed the military to quickly re-equip several key fighter squadrons. They became the first to train intensively on the brand new aircraft. However, transitioning to the new aircraft didn't come without serious problems. Pilots had a hard time adjusting to the unconventional tricycle landing gear. On top of that, its unique center of gravity gave the airplane a nasty tendency to enter a flat spin. This was especially true when returning to base with empty ammunition boxes in the nose. As a result, the accident rate during early training was frighteningly high. When it came time for gunnery practice, complaints about the weapons piled up. The main 37mm cannon constantly jammed after just 2 or 3 rounds. At high altitudes, the gun lubricant would thicken and eventually freeze solid. Pilots simply lacked the physical strength to pull the charging cables. They could not manually charge the 30 caliber wing guns. The nose-mounted 50 caliber machine guns had to be charged by hand too. To do this, the pilot had to unzip a leather boot. This partition separated him from the weapons bay. Then he had to yank hard on the charging handles. But the handles were positioned so awkwardly that getting any real leverage was almost impossible. Plus, toxic powder fumes easily seeped through that leather partition and into the cockpit. The high concentration of carbon monoxide meant pilots quickly developed splitting headaches. This often happened right in the middle of a dogfight. Now let's take a closer look at the design of the production Airacobra. Since the basic engineering layout barely changed after the P-39D was introduced, we will break that specific model down in more detail. This fighter was a classic cantilever monoplane. It featured an all-metal airframe. This structure was built primarily out of lightweight but incredibly strong aluminum alloys. At the factory, the airplane was assembled from 6 major sub-assemblies. These sections were built completely independently. They included the forward and rear fuselage sections, the center wing section, the 2 outer wing panels, and the cockpit itself. This modular design streamlined mass production. The forward fuselage section ended just ahead of the engine compartment. Up in the extreme nose, engineers placed the propeller reduction gearbox and the oil tank. Interestingly, the 37mm cannon fired directly through the hollow propeller shaft. Directly behind this setup were the weapons bay and the cockpit. These were separated by a thick armor plate. Running underneath all of this was a long drive shaft. Below that was the wheel well, where the nose gear retracted. The defining design feature of this fighter was that the heavy engine was not mounted up front. Rather, it was placed mid-fuselage behind the cockpit. It was separated from the pilot by an aft firewall. The carburetor air intake was positioned on top and enclosed in a distinctive fairing. This gave the aircraft its iconic profile right behind the canopy. Picture the structural layout of the forward fuselage. At its core were two heavy-duty longitudinal beams, or longerons. These ran the entire length of the nose section. They were rigidly tied together by bulkheads, the cockpit floor, and the engine block itself. It was between these longerons that all the critical components were mounted. These included the engine, the reduction gearbox, the cockpit, and the forward firing armament. The entire structure was additionally reinforced with stringers. On the outside, the fuselage was skinned with alclad aluminum alloy. It used flush rivets to keep the aerodynamics as clean as possible. Underneath that skin hid a complex web of structural members. To make maintenance easier for the ground crews, the weapons bay and engine compartment were covered by large removable cowlings. Convenient access panels were also scattered throughout the fuselage. These provided quick access to the various internal systems. The nose and tail sections of the fuselage were joined together by standard yet extremely strong bolts. The tail section featured what was then an advanced semi-monocoque design utilizing a fully stressed skin. Its internal structure was made up of 4 longerons, 8 frames, and 2 horizontal panels. The top skin panel could be easily removed for field maintenance. Interestingly enough, right behind the engine, much of the interior space was left completely empty. This was done intentionally to maintain the aircraft's proper center of gravity. Only a few components were housed in this area. These included the coolant expansion tank, the oil tank, and the radio equipment. To safely lift the aircraft with a crane during repairs or transport, specific hoisting points were built into the nose and tail sections. The fighter also had to be securely tied down on the ramp during high winds. To do this, ground crews used special tie-down rings that dropped down from the undersides of the wings. The cockpit was enclosed by a rigid canopy. This gave the pilot excellent visibility to the front, above, and behind. Most of the glazing was made from plexiglass, but the windscreen was built out of laminated material and thick armored glass for combat protection. Right behind the pilot's seat was a heavy-duty rollover structure. Its main job was to protect the pilot in case the aircraft nosed over and flipped on its back during landing. Just imagine, this structure could withstand a massive load of over 35,000 pounds. Another unique feature was the cockpit doors. They were a lot like car doors and hinged at the front. The right-hand door was the main entry point for the pilot to climb into the cockpit. The left-hand door was more of a backup. It actually had radio equipment mounted to it and did not even have a latch to hold it open. The right door, however, had a special mechanism. If you turned and pushed the handle, a metal latch popped out to securely lock the door open. If the fighter took critical damage in combat and the pilot had to bail out in a hurry, he would just yank the bright red emergency jettison handles and both doors would instantly blow clear. By the way, the windows in these doors could be rolled down just like in a car, but instead of a classic rotary window crank, you simply pulled a lever up or down. The pilot sat in a bucket seat stamped out of lightweight aluminum alloy. Interestingly, American seat-type parachutes, just like their Soviet counterparts, fit right into the seat pan. This doubled as a seat cushion. Naturally, the seat came equipped with a robust flight harness. However, there was one major drawback. It could not be adjusted for height at all. Because of this, taller pilots had to deal with a lot of discomfort during flights. The fighter's wing had a complex aerodynamic shape. It featured an airfoil that smoothly tapered from the root out to the wingtips. This gave the aircraft excellent flight characteristics. The wing's angle of incidence was 2 degrees. This was combined with 4 degrees of positive dihedral, which significantly improved the airplane's lateral stability. Viewed from above, the wing featured a trapezoidal planform with rounded tips. Structurally, the wing consisted of a center section and 2 bolted-on outer panels. The internal structure of each outer panel featured 2 main spars, an auxiliary steel rear spar, and a series of ribs. The main spars were fabricated from a lightweight aluminum alloy. To save weight, lightning holes were stamped into all 15 ribs. The wing was reinforced across its entire span by 16 stringers. The exterior metal skin was flush and finished to the same high standard as the fuselage. Removable panels on the underside of the center section gave ground crews quick access to the cooling radiators. The control surfaces, the ailerons, and split flaps were hinged to the rear spar. Each aileron featured a sturdy metal frame. But to save weight, it was fabric covered. The fabric was secured with special clips. This ensured there wasn't a single raised seam to create aerodynamic drag. For in-flight trimming, small plastic trim tabs were fitted to the ailerons. The ailerons themselves had a range of travel of 25 degrees up and 10 degrees down. This gave the pilot excellent roll control. The split flaps were all metal. In cruise flight, they sat perfectly flush against the underside of the wing. This eliminated parasite drag. On approach, the pilot would deploy them. An electric motor smoothly lowered the flaps to a maximum angle of 43 degrees to bleed off airspeed. Rounded wingtips were bolted to the outboard edges of the wing panels. They were built with their own internal framing and smooth metal skin. They completed the fighter's aerodynamic profile. The outer wing panels housed the main landing gear bays, fuel tanks, and oil cooler intakes. They also housed the wing-mounted machine guns along with their ammo boxes. To give mechanics easy access to this equipment, 42 inspection hatches were built into each wing. An electrically heated pitot tube was mounted on the left wing. It was positioned right next to a retractable landing light. Removable fairings were fastened at the wing roots. This ensured smooth airflow where the wings met the fuselage. The tail section of the Airacobra featured a conventional empennage. The horizontal stabilizer was built as a single piece, all-metal structure. Its angle of incidence was 2 degrees and 10 minutes relative to the longitudinal axis of the aircraft. The entire surface of the stabilizer was skinned in perfectly smooth metal. This kept aerodynamic drag to an absolute minimum. The vertical stabilizer followed a similar design. It consisted of a strong internal frame covered by smooth, alclad aluminum skin. Interestingly, the vertical fin was mounted slightly asymmetrically. This counteracted propeller torque and kept the fighter from yawing. Visually, this offset was practically impossible to spot. It was angled just 1 degree off the fuselage centerline. Just like on the wings, the attachment points where the tail assembly met the fuselage were neatly covered by removable fairings. The elevator was split into 2 separate sections, left and right. Each had a sturdy metal frame. The rudder had a very similar structure. However, unlike the all-metal components, the control surfaces were covered in durable aircraft fabric. They were secured with retaining clips instead of traditional rib stitching. The elevator had 35 degrees of upward travel and 10 degrees downward. Meanwhile, the rudder could deflect 30 degrees in either direction. To help manage stick forces on this heavy fighter, the designers added small plastic trim tabs to the rudder and the left elevator. The Airacobra featured a tricycle landing gear configuration with 2 mains under the wings and a nose wheel. This was a highly advanced design for its time. The main struts were solidly mounted to the reinforced inner wing structure. The P-39D variant used large, 26 by 6-inch wheels. These were equipped with modern hydraulic disc brakes. They were operated by toe brakes on the rudder pedals. The nose gear was fitted with a 19 by 8-inch wheel. It was positioned at the very front of the aircraft and bolted directly to the main fuselage beams. To prevent wheel vibration during the takeoff roll, a hydraulic shimmy damper was installed. The nose wheel itself was free castering. It could pivot up to 60 degrees left and right, providing excellent ground maneuverability. The Goodyear tires on all 3 wheels were smooth contour. This meant they had no tread pattern rather than simply being bald from wear. For towing, the nose strut included a mooring ring to attach a cable. When moving the fighter around the ramp, ground crews could insert a tow bar into the hollow wheel axle to steer the heavy aircraft. One crucial detail. Towing the Cobra tail first, a common practice with many Soviet fighters, was strictly prohibited to avoid damaging the nose strut. Additionally, all 3 gear legs utilized Oleo pneumatic shock struts to guarantee a smooth touchdown. After takeoff, all 3 gear legs retracted simultaneously. This system was driven by an electric motor tucked away in the fuselage, just behind the pilot on the right side. The rotation of the motor was transferred to the gear through a system of metal torque tubes. But since electrical systems can fail in combat, an emergency hand crank was provided on the right side of the cockpit. This allowed the pilot to manually raise and lower the gear. During retraction, the nose strut swung backward into a dedicated wheel well in the nose. It was then sealed by metal gear doors to maintain the aerodynamic profile of the aircraft. The main gear retracted inward toward the aircraft centerline. Gear doors then closed completely over the wheels and struts, sitting perfectly flush with the underside of the wings. Once up lock secured the gear in place to prevent it from dropping during high G maneuvers. The pilot could monitor gear status via indicator lights on the instrument panel. As a backup, mechanical indicator pins were also used. When the gear was retracted, bright yellow indicator pins popped up from the top of the wings and the nose. Painted with phosphorescent paint, they were easily visible to the pilot even in the pitch black of a night flight. And if a fatigued pilot forgot to drop the gear on approach, a loud warning horn would sound in the cockpit. At the heart of this legendary aircraft was the American Allison V-1710 engine. It was an incredibly powerful V-12 engine with a highly reliable pressurized liquid cooling system. To prevent overheating, the system ran on Prestone brand coolant. It consisted of distilled water, ethylene glycol, and special anti-corrosion additives. If Prestone was not available at the base, mechanics were cleared to use other antifreeze brands, like American Xerex or British Glycol. But for extreme winter operations, they used a specific mix. It was 80% ethylene glycol and 20% water. This mixture would not freeze even at minus 40 degrees Fahrenheit. To maintain the performance of the fighter at altitude, it was equipped with a centrifugal supercharger. It was mounted to the rear of the engine block and driven off the crankshaft by a step-up gear. Interestingly, the Airacobra used specific variants of the Allison engine, specially adapted for an extension driveshaft. For example, depending on the model, the D, D1, D3, or D4, the aircraft was fitted with the V1710-35. Meanwhile, the D2 variant got the V1710-63. Air reached the carburetor through an upper air scoop. This was not just a design quirk, but a standard requirement for American military aircraft. A pivoting flap was mounted inside the inlet. In heavy rain, snow, or severe dust, the pilot could close it. This allowed the engine to draw shielded air directly from inside the cowling. Starting this massive power plant was handled by an Eclipse inertia starter. Here is how it worked. First, an electric motor spun up a flywheel. Once the clutch engaged, that stored kinetic energy turned over the heavy crankshaft. Power for the starter came from the onboard battery, which held enough juice for about 7 or 8 start attempts. Since this process drew a lot of current, ground crews usually tried to save the battery. They did this by hooking the airplane up to an external power cart. The external power receptacle was located on the lower left side of the forward fuselage. The pilot engaged the starter by pressing a floor pedal on the right side of the cockpit. If external power or a charged battery was not available, the engine could be hand-cranked. Mechanics would pull a hand crank stored inside the right wing root. They would insert it into the starter mechanism and wind it up. This took so much physical effort that it usually required 2 mechanics working together. After 3 to 5 minutes of intense cranking, the starter clutch could finally be engaged. The starter mechanism was accessed through a maintenance panel on the right side of the fuselage, just aft of the engine. Exhaust gases were vented through individual ejector-style exhaust stacks. There was one for each cylinder. Thanks to their design, they provided a measurable amount of usable forward thrust. Because the engine was mounted behind the pilot, power was sent to the propeller through an extension drive shaft. It consisted of 2 rugged tubular sections connected by a spline center bearing. This bearing was bolted directly to the fuselage framework. Up in the nose was the propeller reduction gearbox. It housed 2 massive gears, a drive and a driven gear. Their sheer size was necessary to handle the immense torque of the V-12. This reduction gear featured its own independent oil system. It was fed by a separate 2-gallon tank mounted in the forward weapons bay. Why keep it separate? Because instead of standard engine oil, the gearbox ran on a heavy gear lube. This setup did not require an oil cooler. The fluid dissipated heat perfectly well right inside the tank. All this incredible power was delivered to a 3-bladed Curtiss electric constant-speed propeller. It had an impressive 10-foot, 4-inch diameter. The blades were made of forged steel, but they were hollow to save weight. Blade pitch was controlled by a clever electromechanical drive. This drive automatically adjusted to flight conditions. Meanwhile, the propeller hub was covered by a sleek aerodynamic spinner. For oil cooling, engineers incorporated twin oil coolers. They were housed in specialized ducts at the wing roots on either side of the engine. Ram air entered through intakes on the wing leading edge. It then passed through the cylindrical, 7-stage honeycomb cooler cores and exited out the bottom of the wing. To keep the system running optimally, airflow was regulated by cooling flaps. During combat or patrol, the pilot had to monitor the temperature gauge and manually adjust these flaps. The main engine coolant radiator was mounted right in the center section of the wing. It is often referred to as a water radiator. However, it actually circulated a liquid coolant mixture, not just water. Structurally, it consisted of two identical cores. Cooling air entered through intakes on the leading edges near the fuselage. After passing through the radiator, this warmed air was vented out the bottom of the aircraft. The pilot could manually control this airflow using an adjustable exit flap. Interestingly, some of the warm air was cleverly routed to heat the cockpit and gun bays. Tucked right behind the engine was the coolant expansion tank. Made from a lightweight aluminum alloy, it had an unusual egg-like shape. It held nearly 2.9 gallons of coolant. As for fuel, it was stored in 12 flexible self-sealing fuel cells hidden deep inside the wings. In total, they held about 120 gallons of avgas, with 6 cells on each side. These tanks were a true engineering marvel of their time. They were made of 3 layers of specially rubberized fabric. These layers sandwiched a layer of raw, unvulcanized rubber. If an enemy bullet punctured the tank, this raw rubber layer would immediately swell and seal the hole. This saved the aircraft from fire and leaking fuel. All the cells were connected by sturdy aluminum lines. The right wing could hold about 60 gallons of fuel. Over in the left wing, the setup was a bit more complex. The cells were divided into main and reserve groups, holding approximately 25 and 35 gallons, respectively. They fit snugly into the bays of the wing structure. The fascinating part is that these cells were not bolted down at all. They were simply held firmly in place by the internal structure of the aircraft itself. To access or replace a cell, mechanics used large access panels on top of the wing. The fighter was also refueled from above through flush-mounted filler caps. All the right wing cells could be filled through a single port. The left wing had 2 ports, one for the main group and one for the reserve. The standard fuel for this fighter was high-grade 100-octane avgas. In an emergency, lower-grade fuel could be used. However, this placed severe restrictions on engine performance. Engaging War Emergency Power, or WEP, was strictly prohibited. For long-range missions, all P-39D variants featured the ability to carry a metal drop tank under the fuselage. In an emergency, or once the fuel was spent, the pilot could easily jettison the tank. This provided an extra 75 to 150 gallons of fuel. The oil system also had some unique quirks. The 13.8-gallon oil tank was welded from lightweight aluminum. It was located in the fuselage right behind the engine. You could top it off through a dedicated access panel on the right side of the aircraft. In practice, though, the amount of oil carried always depended on the fuel load. A standard fill was usually around 11 gallons. During training flights, when the aircraft was not carrying heavy ammunition, even less oil was added. Otherwise, it could severely throw off the weight and balance of the fighter. To make engine starts easier in harsh winter weather, the plane featured an oil dilution system. Aviation fuel was intentionally mixed with the oil to thin it out. Once the engine started and the oil warmed up to operating temperature, the fuel simply evaporated out through the breather. Flight controls on the Airacobra used a mixed system. They combined rigid push-pull tubes and steel cables. The cockpit featured a conventional control stick and rudder pedals. The pedals were easily adjustable for pilots of different heights. This made the cockpit surprisingly ergonomic for the time. The P-39 was equipped with a 24-volt, single-wire electrical system. This meant all electrical components were grounded directly to the all-metal airframe, which acted as the return path. Primary power came from an engine-driven generator backed up by a heavy-duty battery. In this aircraft, electricity did almost everything. It operated the retractable landing gear and started the engine. It fired the machine guns and the cannon. It also powered the lighting, radios, and all vital cockpit instruments. For visibility, the aircraft featured a full suite of navigation and recognition lights. Nav lights were mounted in pairs on the wingtips. They were red on the left and green on the right. 2 white position lights were also mounted on either side of the vertical stabilizer. White recognition lights were recessed under the right wing and in the aft fuselage. This allowed the pilot to flash them for visual signaling. On the P-39D2 variant, 3 colored recognition lights were added under the wing. These were yellow, green, and red. They could be toggled individually or together to create different visual codes. Some production blocks even featured special blue formation lights. These were mounted on the fuselage near the cockpit doors for night flying. And for safe night landings, a powerful 240-watt retractable landing light dropped down from the underside of the left wing. All Airacobras carried modern two-way radios. The main transmitter and receiver units were mounted deep in the aft fuselage, but the controls were right at the pilot's fingertips in the cockpit. To make maintenance easier for ground crews, a dedicated radio access panel was located on the left side of the fuselage. The P-39D models carried different types of radios. Some operated on high frequency, or HF, while others used VHF. The antenna setup changed depending on the radio type. The HF setup used a standard wire antenna strung from the front of the canopy to the top of the tail. With the VHF setup, the plane featured a prominent radio mast just behind the engine air intake, routing the antenna directly from there. In addition, the Americans installed IFF, Identification Friend or Foe systems. Basic units only communicated with ground-based radar. More advanced transponders could also ping airborne radar on other aircraft like night fighters. The IFF antennas stretched from both sides of the cockpit all the way back to the tips of the horizontal stabilizer. It is worth noting, however, that these highly classified IFF systems were completely removed from all aircraft shipped to the Soviet Union. The designers also kept pilot comfort in mind, equipping the cockpit with heating and ventilation. Fresh air came through a dedicated vent in the nose, but if the pilot got too warm, he could just roll down the window in the car-style door. When it got cold up at altitude, the cockpit was heated by air drawn from the engine radiator. The pilot could easily adjust the temperature by mixing the hot and cold airflows with a knob located right next to the seat. To keep the windshield clear during flights in icing conditions, it was constantly sprayed with an alcohol de-icing fluid. This simple but effective system also pumped fluid directly onto the propeller blades. This prevented ice buildup and a loss of thrust. All variants of the P-39D used a low-pressure oxygen system for high-altitude flying. It consisted of a mask, a regulator, and 2 400-cubic-inch cylinders. These cylinders were tucked away in the nose compartment. One was mounted in the center and the other on the right side. On some airframes, however, only the right cylinder was installed. The oxygen regulator was a continuous flow type. This meant the pilot had to manually adjust the valve to dial in the right flow for his altitude. The pilot and critical aircraft components were protected by extensive armor. The propeller reduction gear was shielded from the front, bottom, and sides by 5 5/8-inch steel plates. Forward of the cockpit, a 1/4-inch armor bulkhead stood vertically inside the fuselage. It had another angled 1/4-inch plate mounted just below the windshield. To protect the pilot's face, a 1.5-inch slab of armor glass was integrated directly into the windscreen. From the rear, protection was provided by a 1/4-inch steel plate covering the engine and oil coolers. The pilot's seatback was also armored. It was made up of 2 plates that were each 0.2 of an inch thick. Directly behind the pilot's head sat a massive piece of armor glass, a full 2.5 inches thick. This glass was usually housed in a steel frame, though that frame was dropped on later production blocks. All told, the fighter hauled around 245 pounds of steel armor plate, plus another 35 pounds of armor glass. Armament on all D-model Airacobras consisted of a nose-mounted cannon and 6 machine guns. The base P-39D carried a 37mm M4 cannon with 30 rounds of ammunition, but the D1 and D2 variants swapped that out for a 20mm M1 cannon with double the capacity, 60 rounds. The 37mm rounds were fed from an endless belt sitting in a half-moon-shaped tray. Meanwhile, the 20mm M1 used a detachable drum magazine. On early models, the guns were charged by a complex electro-hydraulic system. To simplify things on the D2, this was replaced with a manual charging handle. This handle was located inside the nose gear wheel well. This meant the weapons could only be cocked on the ground prior to takeoff. The actual firing mechanisms were triggered electro-hydraulically. To keep empty brass and links from bouncing around inside the airframe, they dropped into a collection compartment. This compartment was in the lower nose section. After returning to base, the ground crew simply popped open a small hatch on the right side to dump the spent casings. Just above the main cannon, slightly offset to the rear in the nose section, were two 50 caliber machine guns. Their ammo was fed from disintegrating metal link belts. These were neatly stowed in dedicated side bays that ground crews could easily pull out for maintenance. On early variants of the fighter, like the P-39D and D1, each gun had a capacity of 270 rounds. Meanwhile, the D2 model carried 200 rounds per gun. A really interesting design quirk was that the breeches of these machine guns extended right into the cockpit. They were separated from the pilot by nothing more than a leather shroud secured with standard zippers. Because of this, if a weapon jammed during an intense dogfight, the pilot could simply unzip the cover and manually rack the charging handles. Firing was triggered electrically by a reliable solenoid system. To keep spent brass from flying around and damaging the aircraft, casings were collected in designated compartments in the lower fuselage. After landing, ground crews could easily empty them through special access panels. The spent belt links were then dumped into a common hopper along with the cannon casings. Aside from the nose guns, 4 more 30 caliber machine guns were mounted in the wings, safely outside the propeller arc. The inboard guns were shifted slightly forward and upward. This made routing the ammo belts much easier. Since the weapons could literally freeze up at high altitudes, flexible tubes were specifically routed to pipe warm air in and heat the mechanisms. The exposed parts of the barrels were neatly covered by aerodynamic metal fairings. The guns were harmonized perfectly. Their mounts were adjusted so that at a distance of about 220 yards, the lines of fire from all the wing guns converged into a single focal point. The mechanisms were protected from above by canvas covers. The firing system worked exactly like the nose guns. The ammo capacity was pretty massive. It held 1,000 rounds per gun. The long metal belts were stored in spacious ammunition boxes inside the wings. These could be accessed through top maintenance hatches. When firing, the spent casings and links were simply ejected straight out under the wing through small chutes. Initially, these featured spring-loaded doors. However, on the D2 model, they scrapped them entirely to simplify the design. On the main instrument panel, the pilot had a set of armament selector switches. These allowed him to choose exactly which weapons to fire, mixing and matching the cannon and machine guns depending on the combat situation. The main firing trigger itself was traditionally mounted right on the control stick, always at his fingertips. Directly in the pilot's line of sight, mounted above the instrument panel, was a reflector gun sight. To evaluate the attack's effectiveness after returning to base, the shooting was recorded by a gun camera. Early on, it was mounted right inside the cockpit to the right of the armored glass. But on the P-39D variant, they moved the camera into the right wing. This was done to free up space and improve the pilot's forward visibility. In addition to its heavy forward-firing armament, the Airacobra could also do some ground pounding. The fighter could carry a single bomb weighing up to 600 pounds on a centerline fuselage rack. The bomb was released using a simple mechanical cable system. By the way, this was the exact same system used to drop the external fuel tank. However, the fighter did not have a dedicated bomb sight, so when it came to bombing runs, pilots basically just had to eyeball it. It is also worth pointing out the aircraft's extensive standard equipment. Every fighter rolled off the line with 2 toolkits specifically for field repairs on the airframe and engine. On top of that, the aircraft always carried the required technical manuals, a flare gun, a map case for navigation charts, and a first aid kit. It also included emergency rations in case of a forced landing in remote areas. This was provided along with a thermos and a standard issue flashlight.